once we have this, right, we're going to take moment at point C again, right? So we're going to take moment. So let me copy that diagram for you, for us. Right. So we're going to take moment at point D. Sorry, at point C, sorry. We'll take moment at point C, right? So you have some mention about moment Z at point C. The whole thing will be equal to 0. You have the direction of your F1. You have your direction of F2. So F1 and F2 are all going to generate anti-clockwise direction, right? Relative from point C. So F1, so twice, right? F1 is equal to 288 over 233, right? 288 over 233 VT. Hey, Eugene, come on. Right? And then multiply by the perpendicular distance of 3. Okay, so VT multiplied by position of 3, right? And then the V over here is also going to generate anti-clockwise about point C. So plus by V E, right? So the whole thing will be equal to 0. Okay. Right? So VE equal to 6, or 2 times 3 divided by 288 divided by 233 is equal to is equal to 1728 over 233 V multiplied by T, right? So E, so this is minus, right? I have to bring across. So this will be equal to minus 1728 over 233 multiplied by 1 over 8. Okay, so 1728 over 233 times by 1 is equal to minus 0.927, minus 0.927. The minus sign means is on the left hand side of point C. Okay, so it's correct, which is shown down here. Okay, it's going to here. So 1728, let me do it. 1728 divided by 233 times 1 over 8. Yep, 0.927 inches. Okay, so now we know the shear center. Only after we know the shear center, right? Then we can, only after we know that we can apply right, VQ, the shear stress, VQ over IT, right? Okay, now we are going to find stresses at point all the points. Okay, point A, B, D. I'm going to show you how to do that, and we have to be really careful. Okay, so let me do this in a new page. Okay, so we're going to find stresses at point A, point B, point D, point E, point F, and point G. Okay, so we are going to draw the shear flow, right? So this is how our shear flow going to go. So from here, we know that the shear stress at point A is equal to the shear stress at point D is equal to the shear stress at point F, and is also equal to the shear stress at point G, and they are all equal to, so it's equal to A y bar, and is equal to 0 multiplied by y bar, and is equal to 0. Hey, what am I talking about? So for all this, sorry, is equal to 0. Why? Because the Q at point A is equal to the Q at point D is equal to Q at point F is equal to Q at point G. Because this is equal to A y bar, and the A is equal to 0. Right? So if you'll tell me, Eugene, why is that? Okay, so at point A, this is the area. So the area is equal to 0. Point D, the area is equal to 0. Point G, the area is 0. Point F, the area is equal to what? 0. Right? So that's why those are equal to 0. Okay. So now we are going to look at point B. Okay. So point B, we are going to look at the, so we usually call this the flange, right? And this is our web, right? So so point B, there if we look at point B, there are 3 different positions. Okay, 1, 2, 3. Okay, point E is also 1, 2, 3. Okay, and then point C. That is all. That at point C is where our maximum shearing stress will be. So if I'm going to call this point, so this point over here is point B, right? And point B, just the I'll call it web. Okay. Over here will be point B, flange. And over here, this point will be point B, web and flange. Okay. Likewise, over here, point E will be our flange and web and flange. Over here is point E for our flange, and point E on our web only. Okay, but because of rule number 4, where the first moment of area cannot cross the centroid, it cannot cross the centroid, we can conclude this. Yeah, we can conclude this. We can conclude that the shear at point B with web is equal to the shear at point E of the web, and we also can conclude that the shear at point B at the flange is equal to the shear at point B, or not point B, point E of the flange, and the shear at point B for both the flange and web is equal to shear at point E, the flange and web. Okay, so we only need to find 3 locations, and then we have to find tau max. Okay, so the shear force or the shear stress at point B at the web is equal to shear at point E of the web, right? So it's equal to V Q at point B divided by IT. Okay, so we're going to find the Q at point B. Okay, so this is at the web. So at the web, it is this area that I just shaded. Okay, so the width is equal to 1/8. The depth is 2, right? 1/8. The depth is 2, right? And then what am I doing? So I should put this W also. So Q point B at the web, okay? And the distance, the Y bar is equal to 1 plus 3. So this is equal to 1/8. 1/8 times 2 times 4 is equal to 1. Okay, so this is equal to 1 inches cube. Okay, so the shear point B W, okay, point B of the web. So the V is 2.75 times 10 to the power 3. The Q is 1 divided by I think we found the I just can't remember what is it. The I is 233 over 12. And the thickness is 1/8. Okay, so this is 2.75 power 3 times 1 divided by 233 over 12 divided by 1/8. So it's equal to 1133 psi. And this is also the shear at point E of the web. And then next we're going to find the shear, right? The shear at point B in the flange section. Okay, so Q at point B in the flange section, okay, just the flange. So the width is 4. The thickness is 1/8, right? So this is 4 1/8 times by distance of 3, right? Because 6 divided by 2 is 3. Okay. So this is 3. So 4 times 3 times 1/8. So this is 1.5. Okay. So it's 3/2 inches cube. Then you do substitution again. So the shear stress at point B of the flange is equal to 2.75 times 10 to the power 3 divided by I is 233 over 12 divided by 1/8 multiplied by 3/2. Let me tell you what, I'll make our time faster. 2.75 power 3 divided by 233 over 12 divided by 1/8. So this is equal to sorry, silly Eugene, 1133 multiplied by 3/2. Okay, so 1133 multiplied by 3/2 is equal to 1699. Or yeah, 1699.5 psi. Okay, and then we are going to find we're going to find at point B, right, after it clears the web and the flange, right? So we want to find at this dot now, okay, at this dot now, okay. So now this will be equal to Q, okay, so Q at point B, width and flange, web and flange is equal to Q of point B of the flange plus by Q of point B of the web. Okay, so this is equal to 1 plus by 3/2. So 1 plus by 3/2 is 5/2 inches cube. Okay, so therefore the shear stress at point B with the width and flange is equal to 1133 multiplied by 5/2, right? Why 1133? Because 1133 is this value, okay? So this value they have calculated, this is the 1133, okay? So the thickness is constant. Rule number 1, V and I are the same regardless of position. Okay. So that's why those 5 rules works for anything. Okay, in this chapter. So it's 2832.5 psi. And finally, we are going to find. Excuse me. Anyway. You're going to find Q max or maximum shear. So we know that maximum shear, maximum shear will occur, at the centroid. All right. So now we have to include everything now. Right. So the only thing that, oh, this is bad. So we already know up to here already. We already know up to here. Right. So that section is where we don't know. So therefore, Q max is equal to 5/2, right? Plus by the width 1/8, the depth 3 multiplied by 3 divided by 2. So this section that I've just written is over here. Okay, so this corresponds to this, right? So this will be equal to 1/8 times 3/2. So it's 9/16. So 5/2 plus by 9/16. Okay, so 5/2, 9/16 is equal to 49/16 inches to the power 3. So your tau max will be equal to 1133 multiplied by 49/16. Okay, so 1133 to the power 49/16 is equal to 369. Okay, it's equal to 369. No. 1133 times by 49/16. There's something wrong. Is 3469 or 3470 psi. Okay. Now you can only apply this formula over here, which is your VQ over IT, if and only if you know, right, what is this value, your shear center. If you don't know your shear center, you cannot apply the formula. The analysis will be flawed. Okay. So in terms of shear stress, okay, this is the end. Okay. We spent a good 4 weeks on shear stress. Okay, it's a topic that you have not learned before. Okay, and it's a critical one. Next week is your term test. Okay, and then after your term test, we go into Mohs circle. Okay, I'll give you more information. So your term test is up to here. Okay, up to here. I've posted I've posted term test up to here, right? I posted the homework already and with the solution, so you all can work at the same time and not panic. Okay? Term test up to here. Okay. Not working again, cheeky sort. I'm sorry. So term test up to here. Okay. If that's the case, I'm going to finish off early today. Thank you, John, Vivek, and Dajinder. Okay. Have a great evening then. Next week, on Friday is your quiz, and there is no tutorial this week because some of you have a term test in fluid mechanics. Okay. All the best. Okay. That's all. Thank you.
Sir?
Yes.
Do you know anything about the difficulty of the term test? Like
Uh,
relative to the quizzes?